Greetings viewers, welcome to HS Academy. I welcome you to this tutorial video where I'll be teaching physics on this topic known as simple machines. So first of all, in simple machines, one has to understand the definition for a simple machine. So questions may come, define simple machine, what is a simple machine? So a simple machine is just a device used to make work easy. A device used to make work easy. So this is the simplest definition you can go by. Then here we have three types of simple machines. Number one being the wheelbarrow, the second the crane, then third we have the pulley system. Then we also have these three words one has to know: mechanical advantage, velocity ratio, then also efficiency. So number one, here we have mechanical advantage. So how to find the mechanical advantage of a wheelbarrow? First of all, you have to understand what is this same mechanical advantage. So mechanical advantage, it is the ratio of load to effort. The ratio of load to effort, meaning the load is going to be on top when the effort downward. So load, it has an SI unit which is in Newton. Then effort also has the same SI unit. So the SI units end up cancelling. So the mechanical advantage has no SI unit. The same thing applies to velocity ratio. So velocity ratio, on top we have the distance moved by effort. Then downwards we have the distance moved by the load. So the units end up cancelling, leading to the velocity ratio also having no SI units. Then lastly, we have the efficiency. The efficiency, it is calculated in percentages. So we are going to start by the mechanical advantage. So the mechanical advantage of the wheelbarrow. On the wheelbarrow, there is that substance of which we carry, which we are now referring to as the load. Then we have the amount of effort we apply to move the wheelbarrow. So that is what we call effort. Then on the crane, a crane, it is something which looks like this, like a right-angled triangle. So this simple machine, it is used when lifting heavy objects or when pressing heavy objects into trucks or trains. So this is what we call a crane. So here we have this heavy object. We are trying to put this heavy object into this track. So here we have a track. Then the crane, it is pressed at the end of the track. Then here we have the heavy object. So here now the force is going to be applied. The force is going to be applied. When this force is applied, the object is going to be moving until it reaches here. So the distance it is going to travel from this point up to this point. This is the same distance. We say the distance moved by effort. So this distance, it is moved by effort because effort, it is the one causing this object to be moving step by step until it reaches here. So here we have the distance moved by effort. Then the perpendicular distance, it is what we refer to as the distance moved by the load. The load has moved from a point of being at the ground to a point of being at the top. No wonder we use the perpendicular distance to find the mechanical advantage of the crane. Then third, we have a pulley system. So a pulley system, it is made up of the wheel and the axle. So the pulley system, this is how it looks. This is how you are going to find a pulley system. Then there is this which looks like a rope. So here is where your effort is applied in pulling the load, which is this side. So here, this side you have the load and this side you have the effort. So to find the mechanical advantage, you just take the load then over effort. Then your answer will have no SI unit. So here now, what I want you to understand, inside here, we have what we call the wheel and the axle inside these wheels. That is where we have the wheel and the axle. So I'm going to explain more on this wheel and the axle on velocity ratio. So this is just an explanation on a mechanical advantage. So we move on to velocity ratio. So velocity ratio, this is the distance moved by effort to the distance moved by the road. So the distance moved by effort, if it is the crane we are given in the question, the distance moved by effort, it is this one. Then the distance moved by the road, it is this one. Then what you need to know on these questions, always your velocity ratio must be bigger than your mechanical advantage, because efficiency must always be below or equal to 100. Below or equal to 100. It cannot be more. It cannot be more than 100. So the velocity ratio of the wheelbarrow. The velocity ratio of the wheelbarrow, you are going to find the distance moved by effort, then we are over the distance moved by the rod. Then second, we have the crane. The crane here, which is this one, of which I drawn here. So the crane here, when finding the velocity ratio, what you are going to do, so you are going to take this distance of which the effort moved this object, then over the distance of which the rod moved from the ground up to the top. Then after doing that, it means you have found the velocity ratio. Then number 3, we have the pulley system. The pulley system, this is the same as drawn here. So on the velocity ratio, we have two ways in which we find the velocity ratio of the pulley system. Number 1, it is to count the number of rings you have. You are going to count the number of rings you have. So in this example, we have 2 rings, meaning our velocity ratio it is going to be equal to 2. Then sometimes your velocity ratio it is going to be given simply because we want you to find the mechanical advantage. The efficiency already know it is out of 100. Then now let me explain about the wheel and the axle. The wheel and the axle. So I'm just going to take one wheel from these two. So this is just one wheel from these two. So here we have a minor ring inside and a major ring outside. So from the middle point or from the center to this minor ring, this is what we call the minor radius. Then from the center up to the major ring, it is what we call the major radius. So here we have the minor radius, and here we have the major radius. So when finding the velocity ratio of the wheel and the axle, you are just going to say velocity ratio, VR, velocity ratio is going to be equal to radius, major radius over minor radius. Then you are good to go to find your answer. So the wheel and the axle comes from the pulley system. Then lastly, we have efficiency. So efficiency must be equal to or less than 100. So efficiency, we have two ways in which we find efficiency. You can find efficiency in terms of energies, and you can find efficiency in terms of mechanical advantage and the velocity ratio. So number 1, efficiency is equal to mechanical advantage over velocity ratio multiplied by 100%. This is one way in which you can find the efficiency. Then second, efficiency is equals to output NH over input NH multiplied by 100 degrees. So we have two ways in which efficiency may be found. So this is a full lesson on simple machines. So after now understanding all this, you are good to go to answer questions on simple machines. So number one, let me just give you a summary. We started by the definition for a simple machine. So simple machine is a device used to make work easy. Then we had the examples of simple machines: wheelbarrow, crane, pulley system. Then we explained what is mechanical advantage. Then we also explained what is velocity ratio. Then lastly, we talked about the efficiency. So simple machines, this topic, it is very easy. I urge you to pay attention to every word I've said in this video. So this has been Righteous Academy. For more videos like this, subscribe, share, and comment. We need your suggestions, and we have also opened a WhatsApp group. For more information about the content of which I shall be uploading, you can check our WhatsApp group. It is open for everyone.
This is Righteous Academy, where dreams grow wild like a big oak tree. Knowledge blooms like a flower free. Open your mind and let it be. Don't sweat the tough, we break it down. Turn your friends